what is the essence of life? What does every molecule, every single cell need to survive? The answer? Energy. I'm Sukhjot, this is Collen, and this is Dillon, and this is our idea. An idea that comes around once in a lifetime. An idea that will change the way we consume our energy every single day. According to Roland Rosario, head of R&D at Vectren, there are three problematic concerns with the way the state of Indiana produces and consumes energy today. The first is the unpredictability behind high peak load energy demands. Second are the inabilities and difficulties associated with altering consumers' energy consumption behaviors. And lastly are the economic inefficiencies caused by these two variables. To better illustrate this, let's take a look at this graph. Now this graph represents a traditional fixed rate pricing model which is currently used by all utility companies in the state of Indiana today. If you take a look at this section right here, this is demand peak. This is where demand exceeds supply, translating into utility companies having to purchase energy at a higher premium to compensate for the higher demand. Inversely, if you take a look at this section right here, this is where supply exceeds demand, relating to deadweight loss due to the fact energy companies produce too much energy and it just goes to waste.
Now, Mr. Rosario told us in our interview with him that disaggregation is the holy grail to solving these problems. So that's exactly what we're proposing to do. We're going to create an app that disaggregates individualistic APIs of all the appliances inside a home or a business in order to track how much energy they're using. Now, in doing so, that's going to open the door to time-of-use pricing structures for these utility companies. How are we going to do that? Well, there are these sensors that exist that we're going to apply to the mains of buildings to track how much energy is going into that house or business. And by using heater as a back end, we're going to be able to disaggregate that information, and in doing so, we can tell what appliances are on, when they're on, how long they're on for, and that data is going to open the door to this app's proper function. So what we're going to do is create a user interface, two of them. One is going to be for the end user, where they're going to be able to see what's using energy in their house, when it's using energy, and then from that they can make better decisions about how they use energy, especially if time-of-use pricing gets implemented, but I'll get back to that. Utility companies are going to have their own user interface where they can see where energy is being consumed within the city, how much of it's being consumed, and they can use that data to make better decisions about purchasing and pricing of their energy. So let's talk about time-of-use pricing a little bit. Currently, the solution is to just draw an average line right through the middle of the graph. It's the same price no matter what the demand is any time of the day. Time-of-use pricing changes that paradigm by costing more during peak loads in order to discourage people from using energy during those times, and less during off-peak hours to encourage people to use more energy during that time. The idea being that it can kind of level out and in doing so eliminate those deadweight losses that we discussed previously.
The electric industry is a $319 billion industry with an expected growth rate of 13.5% over the next 5 years. Now, there are several different factors and things we took into consideration when coming up with our solution. The increase for demand of real-time time-of-use pricing, the ability to be able to track your inefficiencies and see how you can better increase your efficiencies throughout your house or business, and then the increase in government regulations to cut down on these inefficiencies from power coming from the power plant to your house. Now, there are a total of 9 companies in Indiana, they account for $9 billion of the market share of the $319 billion. But we want to start by targeting just the first 4 companies. These are the 4 biggest in Indiana. All 9 companies have their own territories, so they are a governmental monopoly.
So how are we going to do this? Well, to better articulate this, we created a business model canvas that articulates how we're going to create value, how we're going to deliver value, and how we're going to ensure a financially stable business model for the long run. And just a quick note, the cost structure was cut off due to the dimensions of the PowerPoint, which we'll get to later. But in order to understand this business model canvas, we have to first look at this section right here, which is the value propositions for both the end users and the utility companies. Now, for the end users, we're minimizing household energy costs through the disaggregation of individualistic APIs, translating them directly to real-time cost. Inversely, we are benefiting the utility companies by reducing energy market inefficiencies by providing them a platform to alter consumers' behaviors, resulting to better production and delivery of energy. So in order to provide this value, we have to execute a few key activities. First is we have to install sensors on each house. Second, we need to develop a UI and a UX interface for both the utility companies and the end users to ensure for an intuitive functionality to provide the optimal experience. Thirdly, we need a UI, UX maintenance team to ensure that everything goes to plan and there are no issues with both the utility company side and the user side. And lastly, we need to integrate with existing legacy systems that Vectren has already. In order to achieve these key activities, we need a few key resources. The first is obviously software operating system. We need sensors, obviously, to put on the household fuse breaker boxes, we need to put this on an app store, have Care's backend system to power the disaggregation aspect, and also have a hub-based server to store all the data to provide better analytics.
So we have two customer segments, one being Vectren, which is actually going to buy the product from us and implement it into their services, and then the end user being the household or the business through Vectren, in which are going to get the benefits from our service. Now we are going to ensure that the products are installed right by taking Vectren's technicians out of the field, training them with our product and our knowledge to ensure that they can run out, they can do service calls, they can troubleshoot our systems so that we don't constantly have to run around for it. We're also going to offer in-app recommendations in the app to tell you where you can save more or what you can cut down on to reduce inefficiencies. Now the one big problem with this is we have to educate the customers on why they should switch to this and why they should use it. So we're going to have to utilize Vectren social media, our social media pages, other social media pages of the power companies. We're going to have to get downloads through our App Store, Google Play, and then iPhone. Then we're also going to have to use local testimonials in the community and then the different media outlets in the community.
So in order to ensure that we're providing the value we promise to our customers, there's a couple of key performance indicators that we're going to track. The first one's going to be a purely utility company type of metric. We're going to watch power factor, which is allowed to us by using those sensors on the mains, which is essentially just a tracking of how efficiently the energy is being transmitted through the grid. Secondly, and maybe more importantly, depending on your perspective, we're going to track and log information about how people are using energy. From that, we're going to be able to implement predictive analytics, both for the people and the utility company, so they can make better decisions. And that's going to translate to cost savings, which we'll also be able to track because we can look at the billing information provided by Vectren. But how are we going to pay for this company? Well, if you look at our cost structure, it's pretty simple, very basic. We're just going to have rent, salaries, that sort of thing. Things to note, though, is during the first year, we're going to have a few expenses that will not keep going, like the development of our actual software, the IT support team, and, of course, the actual data storage to put all the data on. Now, revenue streams is also very critical to what's going to keep us going. What we're going to do is charge the end users $5 to put the sensors on their house, charge Vectren $2 per operation, and that's just to cover the costs of putting our hardware onto these people's houses. Now after that, we're going to charge the end users $2 per month on their bill in order to pay for the service we're providing them. It should end up saving them a lot more money than that, so it is of value to them. And finally, we're going to charge Vectren $5 per user in order to keep our services operable and our company profitable.
So in conclusion, we're minimizing household energy costs through the disaggregation of individualistic appliances and their APIs translated to real-time cost. Inversely, we're providing energy companies the ability to alter consumers' behavior to reduce market inefficiencies in the way we produce and consume energy today. Thank you.